we are covering soil phase diagrams, a critical topic in the geotechnical engineering section of the FE Civil exam. All weight-volume relationship problems start with visualizing the three-phase diagram, which conceptually separates a soil sample into its three components: solids, water, and air. The key to solving these problems is understanding the relationships between the volumes and weights of these components. First, let's focus on the two most important volume ratios: void ratio, E, and porosity, N. The void ratio is the volume of voids divided by the volume of solids, while porosity is the volume of voids divided by the total volume. A classic exam trap is confusing these two because their numerators are the same. Always double-check whether the denominator should be the volume of solids for void ratio or the total volume for porosity. Next, we have water content, W, and the degree of saturation, S. Water content, often expressed as a percentage, is the weight of water divided by the weight of the solids. It is a very common mistake to use the total weight in the denominator. The degree of saturation is the volume of water divided by the total volume of voids, indicating how much of the void space is filled with water. A completely dry soil has S equal to 0, while a fully saturated soil has S equal to 100%. Now for the single most valuable shortcut on the exam for this topic, a formula that connects these key properties. SE equals WGS. That's saturation times void ratio equals water content times the specific gravity of the solids. A good way to remember this is with the phrase SEWAG. This equation is your key to solving for an unknown when you are given 3 of the 4 variables. For example, an exam question might state, a soil has a water content of 18%, a specific gravity of 2.65, and a degree of saturation of 90%. Find the void ratio. Using our formula, E equals WGS divided by S. So, you would calculate 0.18 times 2.65 divided by 0.90, which gives a void ratio of approximately 0.53. Once you have the void ratio, you can solve for any of the unit weights using the formulas found in the Civil Engineering section of the NCEES FE Reference Handbook. The dry unit weight, gamma D, is GS times the unit weight of water, all divided by 1 plus E. The saturated unit weight, gamma sat, is GS plus E, all divided by 1 plus E, and then multiplied by the unit weight of water. You must know the unit weight of water, which is 9.81 kilonewtons per cubic meter in SI units, or 62.4 pounds per cubic foot in USCS units. Finally, the submerged unit weight, gamma prime, which is crucial for effective stress calculations, is simply the saturated unit weight minus the unit weight of water. Pay close attention to the units and whether the problem provides weights or masses, as this will dictate whether you are calculating unit weight, gamma, or density, rho. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.